to find this one and that one. Okay, so this one means you're going to take the partial with respect to x, and then with respect to y, and then with respect to z, right? But you can do, if a different order looks easier, you can do that, okay? The easiest thing is to take your partial with respect to x because what's that? So what is the partial with respect to x? Well, there's just an x in the numerator. That's the only place that x appears. So what do you think the partial with respect to x is going to be? Okay, so this can be rewritten as a product. I think that might be the best, that might be the easiest way to look at it as a product. So just take this, so the partial of this with respect to x, you treat all this as if it's just a constant. And so you're just gonna get this part because the derivative of that's just 1. So you just get that part, y plus 5z to the minus 1. Okay, and then you want to take the partial with respect to of that with respect to y. Okay, so we've already done the partial with respect to x. Now it's partial with respect to y. So it's just the derivative of this, treating this part as a constant. So that's negative y plus 5z to the negative 2. And then you take the partial of this result with respect to z. So you have a negative 2 coming out, and you're going to have a 5 come out. So that's going to be 10. And that drops down to the minus 3. And so then that's 10 over y plus 5z to the 3rd power. And we'll see if that's the case. Yeah, and so Webassign agrees that that's the answer. And then the second part, this one right here. Again, what this is saying is to take the partial with respect to y first, and then take 2 partials with respect to x. Okay, but it's going to be easier. Here we have the partial with respect to x, so we can already go off of that already. And then take the partial, so if you take the partial again with respect to x, wait. The 2 goes there on the x, not on this part. But up here, the number goes here. Just the notation. Okay, so if you take the partial of this with respect to x, what do you get? Anybody? So there's no x's in here. And this is just, you're supposed to treat this as a constant. So the derivative is going to be 0. Yeah. Yes. So then, okay, so now if you take the partial of this with respect to y, that's also going to be 0 because it's just 0 already. But this is the same as this one. Okay, this is the same as that. Okay. So you can swap the order. There's certain rules. There's a rule for swapping the order, but that for almost everything that you're going to be doing, that rule is allows you to do it. Okay. It's only in these like weird situations that you're never going to see come up. that you can't swap these, okay? You can't take the partials into a different order and get the same thing. Okay.